Hello everyone. I hope you are enjoying the DSA 30 days challenge, right? So this is the last challenge I given. Challenge number 70. Yeah, I explained the problem also, right? You can see the problem once again. So we have to find out number of islands, right? Number of island. What is the island definition also I explained. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all are surrounded by water. Right? Next one. What is the meaning of land here? What is the meaning of water here? Remember, in a matrix, 1 means land, 0 means water. An island is surrounded by water and is formed by, right, connecting adjacent lands together, right, horizontally or vertically. So I have so many examples, I can give that also. So I think if you see the first example, see the first example, I think this is one row, this is a one more row, this is a one more row, this is a one more row. If you write the properly, you will get the clarity. So triple one, right? Let me see some 1, 2, 3, 4, 5. Yeah, I think 5 columns. Triple one, 1, 0. Right? Triple one, 1, 0. If you want, I will write the matrix format. Next, double 1, 0, 1, 0. Next is going to be triple, right? Double 1, triple 0. Next, I think 5 zeros. So this is the matrix given. You have to find out number of islands. Let's check. All adjacent ones. Remember, adjacent, horizontal or vertically, whatever it is. So I think this is one island. Let me know if I am wrong. Please let me know. So output is 1. Number of islands you have to return. See, they all are adjacent. They all are adjacent. Yeah, fine. So in the similar way, second example also you can see. Similarly, second example also you can see. Let's see this one. How many rows? 1, 2, 3, 4. 4 rows are there. How many columns? I think 5 columns. So I will try to adjust here. 1, 2, 3, 4. 4 rows. Columns are 1, 2, 3, 4, 5. Right? So let me write one by one. First one, double 1, triple 0. Double 1, triple 0. Next one is double 1, triple 0. Next one also double 1, triple 0. Okay. Third one is double 0, 1, double 0. So last one if you observe, triple 0, triple 0, double 1. Triple 0, double 1. Yeah, you can find out how many islands are there. Can you find out? I think this is one. Adjacent people. All adjacent people you have to take. All adjacent people. Try to remember. All adjacent people. This is. See, let me check. Once. So this is one. This is one. So this is one. Check. If anyone having any doubt, 3. Fine. So I think 3 islands. That's fine. Let's go to bigger picture. You will get more clarity in this. This is one. This is one, right? This is one. This is the one more one. This is one more one. This is the one more one. Remember, these are not adjacent. These are not adjacent, remember. These are not adjacent, remember. Right? These are not adjacent, remember. Right. You cannot say two diagonals taking their adjacent. You cannot say this. So like this, I think how many can you count? 1, 2, 3, 4, 5, 6. 6 islands. 6 islands are there. Right? Be careful, 6 islands. I hope everyone is fine now. Right? Let me go here. I think the answer for this one is, I think if you observe clearly, if you consider it as a graph, the answer for this one is you can apply BFT or DFT. It is something like problem looks so scary. Problem looks so scary, but actually it is the BFT DFT, finding number of connected components. It is one connected component, it's one more connected components, finding number of connected components. Right? But in the case of the graph, if two people are adjacent, you will take it. But here, right? So two people are surrounded, something like all one, surrounding ones you will take. They're surrounding, right? Surrounding vertices, adjacent vertices you will take, but here, right? Surrounding ones you will take. That is the only difference. Simply the answer for this problem is, right? Apply BFT, DFT. So I'm writing here. This problem is similar to. This problem is similar to finding number of connected components. Connected components in the given graph. And one more, to find out the finding number of connected components. For this purpose, you can use BFT also, breadth first traversal. DFT also, you can use anyone. Whatever you feel, you can use. Right? In the graph, two people are adjacent. Maybe adjacency matrix, adjacency list they will give. Right? But here in some other way, one matrix is given. Right? So adjacent people are ones. Adjacent people are ones. Group them. If adjacent people are 0, don't group them. Right? That's what it is going on here. Different way of saying it's one of the well-known graph problem. Connecting, right? Finding number of connected components. Right? So I written some small code also. See this one. One matrix I took. I called, right? Count islands. Right? So when you call the function count islands by sending the matrix, so what that particular one will do is every row, every column it will scan. Every row, every column it will scan. Right? So whenever it is scanning, I is equal to 0, j is equal to 0. When it is scanning, first it will check. Is it visited or not. If not visited, then it will call DFT algorithm. DFS algorithm it will call. Right? DFS algorithm, it is a DFS algorithm. It will call this. Whenever DFS algorithm is going on, first it has to check. Is it neighbor or not? Adjacent or not, it will check. First it will verify, is it adjacent or not? If it's adjacent, and one more thing is marked as, right? If it is adjacent and one more thing, it is not covered. If it is not covered, adjacent and it is not covered. Adjacent also and it is not covered. See. Using this function, using this isSafe function, I will calculate is it adjacent or not. And one more thing is, I will check is it visited or not. Adjacent and not visited. And once also, if it is adjacent and one, right? Then what I will do is I will call DFS algorithm for that. Simply DFS. Remember, simply DFS. Right? You have to check carefully all the actions. Adjacent or not. So adjacent or not. So these are the things which will take. My surrounding people like this. to me, by adding this one, I will get the adjacent people. If at all I am adjacent and not visited, call the DFS algorithm again. Right? So like this, one is already there. One is already there. So next one, should I take or not? So adjacent or not will verify, right? And one more thing, is it one or not verify? One and adjacent called DFS. Right? Next one. Once again, adjacent and one are not verify. Adjacent one are not verify. Adjacent one are not verify. Adjacent one are not verify. Like that, it's keep on going. It's keep on going. So you will group them. Right? You will group them. Then you will count the number of connected components as +1. So every time you will keep on count it. Every time you will keep on count it. Whenever C1 count is 0 initially. Number of islands are going to be initially 0. After everything, you will increment the count by 1. See, you will increment count by 1. Lastly, return count. That count comes to here. So it will be printed. Some rules and regulations, right? Some rules and regulations. First of all, verify. See this one. Whoever you want to try, first of all, verify. Is he one? Yes, one. And one more. Is he not visited? Yes. First of all, whoever you want to go further, you want to count it as an island. First of all, is he one or not? Yes. And is he not visited? Yes. Then call DFS. In the DFS algorithm, it will check all neighbors are what? Is it safe or not? What neighbors and all. If at all neighbors, if you find out someone else is not visited, again call DFS. Keep on going like this until zeros will come. Right? So then after completion of total story, count ++. Right? After completion of total story, count ++. Right? It's keep on going. For every iteration it will verify. So because of one scanning is going on, right? Order of M time complexity, order of M rows and N columns. Right? That's it. So space complexity is order of M. Same way. One table required for visiting purpose. Is he visited or not? Because of here MN people are there. Visiting marker purpose, order of MN. Simply those people who are not getting BFS. Please understand BFS. It is exactly like counting number of connected components.